All right, cool. Let us begin. Okay, so what I have done is I have 4 bottles of different chemicals that I've put out, and I'll write down the list so you guys know what we are working with. The first one we have is lead nitrate. I'm going to write this here to represent that it's lead 2. And it is PbNO3 Just getting you guys used to seeing both the word version and the symbolic version. So that's our first solution that we have here. The second solution that I'm going to be giving you guys is sodium hydroxide. Got the R in hydroxide. NaOH. It's this guy here. We should actually start with some of our observations. So this one here, what do we notice the color of that? It's got no color. So we call it colorless. And we write AQ because AQ represents aqueous. What about the sodium hydroxide? Colorless as well. Lots of things chemistry-wise are colorless or white. And again, we'll go AQ because we know that's aqueous. Right after that, we have potassium iodide. I'm running out of space, so how am I going to squish it? Iodide. And again, color? No color. Colorless. AQ. And then the last one we have is our copper sulfate. This guy is blue and also aqueous. Sorry about that. All right. Are we cool with that? Yes? No? Okay. I did not leave enough space, which is not ideal, but we will make do. All right. So each one of these solutions I want to mix with something else so we can test what precipitates are forming and then which precipitates have formed. So I'm just going to start by making it a nice little table. Like so. And because I didn't plan for enough space, I'm just gonna write the formulas over here when we're mixing them. All right, so now I'm just going to copy down my list going down so that way we can crisscross all the different items. So I'll start with the lead nitrate. We'll put lead nitrate here. It's a little bit squished, but that's okay. I'm going to try to halfway this page so that way we can kind of space it out well. So basically we're creating a box. So lead was our first one, sodium hydroxide was our second one, potassium iodide, and copper sulfate. So I just basically want to make a grid so that way I can keep track of what I've mixed with what and what I've noticed observation-wise. Now obviously with the things that are both the same, we're not going to mix them together because there's going to be no reaction because there's the same compound. So this lead here and this lead nitrate, that's the exact same thing, so we're not going to do that experiment. This is sodium hydroxide. This one's also sodium hydroxide, so we won't do anything there. This one's potassium iodide. That one's potassium iodide. We won't do anything there. And then this one's copper sulfate. That one's copper sulfate, so we won't do anything there. But everything else we will mix together and we will make observations on whether or not a precipitate forms. The other thing to keep in mind while we are doing this is how many test tubes you're going to need to do this reaction. So in a moment, when you go grab your solutions, you're going to need enough test tubes for all these reactions, or you can just wash them out and reuse them. It's not too fussed. If I was looking at this, how many test tubes would I need? 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? We okay with how I got to 12? Okay. If you don't want to grab 12, you don't need to grab 12. You can just wash them in between. All right. So what you guys are going to be doing in a moment is you are going to take your two intersecting solutions, just like you would as a Punnett square, and mix them together to see if a precipitate forms. I'm doing mine in a beaker to make it a little bit easier for us to all see. So I'll do the first one here. We have sodium hydroxide. So I'm going to put that into my beaker, like so. You are obviously going to use test tubes for yours. And then I see, okay, with the sodium hydroxide, I want to add lead nitrate. So here's my lead nitrate. I'm going to add it in. Oh, looks like I need to add quite a bit. There we go. I don't know if you guys can see it easily. I'll hold it up, but we see that it's kind of white and cloudy now. Yeah? So that tells me a precipitate has formed. It's kind of milky. So what I want you guys to do is to figure out what two potential ionic compounds there are, and then use the solubility rules to justify which one it is. So if I'm mixing the sodium hydroxide and the lead nitrate, what we're going to be doing is we're looking for the cation ions and the anions, and we're swapping them around. Do you guys remember what cation ions and anions are? Hopefully. So the cation ions are the positive ones, and the anions are the negative ones. So either or, you want to switch them around, that's fine. So I am going to go with the sodium is now going to be paired with the nitrate. And I'm happy if you want to do it symbolically or if you want to write down the words. So that's one of my potential products. The other one, I see there's hydroxide here, and that hydroxide is going to go with the lead. Those are my two potential products. Happy if you guys want to write it out as the names, or if you want to write it out in the formula at this point. I will talk about what the expectation is for the assessment next lesson, I think. We good? All right. So now that I have that information, we want to figure out which one is that white solid we saw forming. So you're going to use your resource sheet, and we are looking at our solubility rules here. And those are my two choices. So the first rule I see is that all group 1 compounds are soluble. So if I think about group 1, we are talking about, in that periodic table, that first column. In that first column, do I see something that is related to what I see up here? Sodium. So since sodium is all group 1 compounds are soluble, this one here is probably soluble too. So I'm going to just make a note that this is probably my aqueous one, AQ. I can also look up nitrates on my list, and I can see all nitrate compounds are soluble. So with those two bits of information, sorry, I got to precipitate. So we can assume that it's probably our lead hydroxide, but let's double check it by, again, looking at our solubility rules. So there's nothing here with ammonia. If you guys are wondering what ammonia is, we're talking about NH4+. Nitrates are all soluble. If you guys are wondering what nitrate is NO3-. Most sulfates are soluble. You don't have any sulfates, that's SO4-2-. Most halides are soluble. So halides, for those that aren't sure, that is group 17. The halogens. Again, we're not dealing with any of those. Next one is all carbonates. We don't have any carbonates, but so you're aware that's CO3-2-. It says all hydroxides, sorry, all oxides. Oxides are O2-. hydroxides are OH minus, are insoluble. So that's already like sounding my alarm bells because I noticed that I have lead hydroxide. So that's already suggesting to me that based on this rule here, this is what is insoluble. But I have to double check the exception. So it says except those in group 1, is lead in group 1. We look at our periodic table. No. So it's going to be the soluble product. Except in group 1 and those that are the ammonium ions. That's not the ammonium ion. We know that's what the ammonium ion is supposed to look like. So that is telling me that one's the solid, and it is a white color. It's very important that we note down our observations. And just to double check, our last one is all sulfides are insoluble except for those in group 1. Sulfides are 2S minus. And again, we don't have any of those, so we're not worried about that. Are we good so far? All right. So the next thing then is to justify why we know that is our precipitate. Let's grab another piece of paper to write that down. That's my justification. So we're justifying. So lead 2 hydroxide is the white, and I'm happy if you guys want to abbreviate precipitate as PPT. In the reaction between NaOH, and now I'm being lazy, because all hydroxides are insoluble with the exception of group 1. Ions. Lead is not in group 1. Oops. In group 1, therefore, I'm happy if you want to do those little dots to help shorthand. Therefore, lead hydroxide is insoluble. So we're just justifying our choice. So I'm happy, again, like I said, you can either use a Google Doc and make the template and write it in, or you can just hand write it on a piece of loose paper to then hand in to me. But I want to make sure you guys know how to use your solubility rules and how to justify it. It gets you set up for what the internal is going to require you to do when it comes to the justifications and things like that. Sound good? All right, what questions do you have? No? All right, so the aim for this period is to get all these guys mixed together, make your observations, do your justifications, use those solubility rules for your justifications. I would say focus on getting all the practical stuff done first, because whatever you don't finish, then you can write up at home. Cool? All right, I'll get out the goggles. I have some nicer goggles for you guys. And that's mostly it. I'll get the test tubes and the test tube racks out too.